Welcome to the Podkey summary of Build AI-powered scripts with the CLI and Python SDK from WWDC 2026. Apple's making its foundation model stack feel a lot more usable for everyday development, and the big theme here is convenience without a lot of setup drama. There's a command line tool already sitting on macOS 27, a Python SDK for notebook and data science workflows, and a pretty practical push towards structured output, tool calling, and real evaluation instead of prompt guesswork. A lot of this comes down to one nice idea. You can start locally, with no API key and no cloud bill, then reach for the bigger private cloud compute model when the task actually needs more horsepower. The easiest entry point is the FM command line tool, which ships pre-installed on macOS 27. That matters because it removes the usual friction. You don't have to spin up Xcode, rebuild an app, or wire together a bunch of scaffolding just to test a prompt. You can just open Terminal and start talking to the model. It supports interactive chat if you want an ongoing back and forth, and there's also a plain respond mode that fits nicely into scripts and shell workflows. There's a schema command too, which is where things start getting genuinely useful. Because now you're not just asking for words, you're asking for output in a format your code can actually rely on. And a couple of small commands do a lot of work here. Model lets you switch between the on-device model and the private cloud compute model, and /save lets you keep a conversation around for later instead of losing it to terminal history purgatory. Guided generation is one of the clearest practical upgrades in this whole setup. Using the FM schema object, or the @fm.generable decorator in Python, developers can force the model to emit JSON that matches a predefined schema. That means no more fragile little parsing tricks where you hope the model puts a colon in the right place and doesn't suddenly get poetic. If your downstream script expects a list of draft files and final files or item suggestions in a fixed structure, it can get exactly that and move on. It's a simple idea, but it changes the model from something you manually inspect into something you can plug into automation. One example here is a shell script that uses FM respond with a custom schema to classify files as drafts or finals. Then the script moves drafts into an archive and backs up the finals. What's nice about that is it doesn't depend on rigid file name rules. If your naming habits are chaotic, or let's be honest, just very human, the model can still interpret natural language instructions and make sense of the mess. That's a good snapshot of where these local models are handy. Not magic, not all-knowing, just flexible enough to deal with the real world where folders are rarely pristine. The Python SDK is the other big piece, and it's clearly aimed at ML engineers and anyone who likes to prototype in notebooks before committing to app code. It installs with pip on Apple-Silicon Macs running Python 3.10 or later, and it mirrors the Swift API, so the concepts carry over instead of living in separate worlds. It supports the same core features: text prompting, image prompting, streaming, guided generation, and tool calling. Because it's Python. It also plugs into the usual data science ecosystem. You can work in Jupyter notebooks, run evaluations, and connect outputs to tools like Pandas and Matplotlib without doing awkward translation work. Two capabilities broaden the picture quite a bit: image input and tool calling. Image support means this isn't just text in, text out. You can classify visual content or describe a screenshot directly from the terminal or from a Python script. Tool calling is the bigger jump. If you care about building assistants that can actually do something. Developers can expose custom functions, like fetch_last orders, and the model can invoke those during a session. That turns the model from a chatbot into something more agentic, where it can work with app context and user data through controlled functions instead of free-form guessing. The appeal here is that this can happen with on-device models too, which helps keep those interactions local and safer while still being useful. The on-device versus private cloud compute split is probably the most important product decision underneath all of this. By default, the on-device model runs locally. It's always available, and there's no API key, no rate limit anxiety, and no surprise cloud bill hanging over experiments. That makes prototyping at scale much easier, especially for teams that want to try lots of ideas without turning every test into a budget conversation. The trade-off is that the local model is smaller, so it's naturally less capable on more complex tasks. When you need better performance, the same API can point to the larger private cloud compute model. You get more capability, but now you're dealing with usage limits and possible billing. So the workflow is pretty sensible. Stay local by default. Switch up only when the problem earns it. One of the more grounded parts of this story is the prompt engineering trade-off they surface through evaluation. Highly detailed prompts reduced hallucinated items, which sounds great, but they also increased generation errors, often because they pushed into the model's max context window. Simpler prompts had the opposite problem. They were more robust in one sense, but they added more extraneous items to the cart. So there isn't a single perfect prompt style. There's a tuning problem here between specificity and reliability, and the right answer depends on the use case. That's useful, because it replaces the usual mythology around prompting with something much more normal. Test it, compare it, and accept that trade-offs are part of the job. The evaluation pipeline in Python makes that process feel concrete. Multiple prompt implementations are run against a shared evaluation dataset, and the outputs go into a pandas data frame, so they can be compared side by side. Then a separate judge model scores the results using custom criteria, and those scores can be visualized with matplotlib. That gives developers a quick way to spot which prompt strategy is actually performing best instead of choosing based on vibes, which, to be fair, is still how a lot of prompt decisions get made. Taken together, this is a pretty approachable stack. A built-in CLI, a Python path for experimentation, structured outputs that are easier to trust, and a local-first model story that keeps the barrier to entry low. It feels less like AI as a demo, and more like AI as a tool you can actually poke, measure, and fold into normal development work. This episode was generated by Podkey. Create your own at podkey.fm.